Any number, so any number that's just like 2i, or I by itself, or negative 4i, these are pure imaginary. That's what those are called, pure imaginary. Complex numbers have a real number added or subtracted to an imaginary number. So they have a real part and an imaginary part, so that's why they're complex. So they're not actually complex, as in complicated, they're complexes, and they have numbers from both the real number system and the imaginary number system. So these are complex. And complex numbers are of the form a plus bi, where a is real, bi is imaginary. So treat your i's exactly the same way you would treat an x or a y at this point. It's just like a variable when you're adding or subtracting. I have a negative out front, so I need to distribute that negative in. So this gives me negative I minus 5 plus 5i. I have a negative I and a positive 5i, so negative 1 plus 5 is 4. So you've been doing this the whole time, except you were using x's and y's instead of I. And you'll notice in no problem up to this point did they ever use I as a variable, because I is imaginary, so he's special. Another subtraction, so I'm going to distribute that negative. So this is 6 minus 2i minus 3 plus 3i. 6 minus 3 is 3, negative 2 plus 3 is 1. And you always put the real number out front and then the I in the back. That's standard form. So even if this number out front was negative, and I know that looks weird, you put the negative first and then the positive.
I understand using the imaginary number because of the negative square root, but what purpose does it serve in expression? Just to make it work?
No, there are applications of this in like engineering, quantum mechanics, higher order physics. And to be honest with you, I don't really know that math. Like I know this math that they use, but I don't know what they are using it for.
Just not to know it exists.
Yeah. I didn't do applied. So adding is really easy. 4 plus 2, 6. Negative 2 plus negative 3, negative 5. All right, so now we'll go to multiplying complex numbers. This gets a little bit more complicated. We're going to FOIL this, same as you've been doing. So first, outside, inside, last. So I have negative 1 times negative 4, so that's positive 4. Negative 1 times 2i, so that's negative 2i. You just multiply the number times the number. Negative 4 times 4i, so that's negative 16i. And then 4i times 2i, 8i squared. This. 8i squared is 8 times negative 1. You never leave an I squared hanging around. So this is negative 8. So I have 4 plus negative 8, so that's negative 4. Right, so 4 plus negative 8. And then I have negative 2i minus 16i, so that's negative 18i. So the process, same as you've been doing. The only difference is instead of having, like, if you had an x squared, you just leave it x squared. But I squared is negative 1, so we never leave it I squared. We basically change the sign of this number and combine it with this one over here. Does everybody have this? Okay. Distribution, standard, same, multiply by each. Negative 3 times 1 is negative 3, so I have negative 3i. Negative 3 times 2 is negative 6, and then I have I squared. But I can't have I squared. So that's the same thing as negative 6 times negative 1, which is positive 6, and the number has to come before the I. The last one, I'm going to FOIL. So first, outside, inside, last. Kind of looks like Cartman. Okay, so 4 times 6 is 24. 4 times negative 2i. 6 times negative 5i. And then negative 5i times negative 2i. 10i squared is negative 10. So I have 24 minus 10, so that's 14, and then negative 8 and negative 30, so minus 38i. Dividing. Big fat no-no. You can't have I in your denominator. So remember our complex, or our conjugates before? Well, we're going to have now something called a complex conjugate. And that's if you have A plus BI, it's A minus BI. First sign stays the same. The only sign that changes is this one in the middle. So we don't care if this is positive or negative. This is the only one we care about. So I'm going to multiply by negative 3 minus 4i.
So the 3 stays negative?
3 stays negative. We don't change the sign. It's just the middle sign that changes. Yeah, we were just doing that. So I have negative 5i times negative 3 is 15i. And then negative 5i times negative 4i is positive 20i squared. And then because these are complex conjugates, my middle terms are going to go away again. So I don't have to multiply all that out. I would get plus 12i minus 12i if I did. But because we're talking about conjugates, we only have to multiply the first and the last. So I get 9 minus 16i squared. This is negative 20 plus 15i. And this becomes positive 16, so that's 25. 20, 25, and 15 will all divide by 5. So I can only reduce this if all of them will divide. Kind of like with roots, with the square roots. This is the same idea as with square roots, except we've got an I now instead of a radical. So this is negative 4 plus 3i over 5. Negative 5 plus 3i, negative, or 2 minus 3i, so I'm going to multiply this by 2 plus 3i over 2 plus 3i. I have to FOIL the top, so I have negative 10 minus 15i plus 6i plus 9i squared. And on the bottom I get 4 minus 9i squared, because I only have to multiply the first and last. So this is negative 9, right? Because I squared is negative 1, so that becomes negative 9. So I get negative 19. And then negative 15i plus 6i gives me negative 9i. And that becomes positive 9 down here. So that's over 13. Nothing is going to cancel, so we're done. We don't have a conjugate, right? We don't have an expression. I only have a pure imaginary number. You just multiply by I. Because I just need to cancel the I out. So all I'm doing, if you have just a pure imaginary number, you just multiply by I. You don't have to multiply by anything else. So I get negative I, because I have, 1 times I, plus 6I squared over negative 2I squared. So this becomes negative 6 minus I over 2. That becomes negative, cancels each other out. That becomes negative, makes this negative 6. Yes.